Hello everyone and welcome to yet another tutorial in the TinyML series. Today I'm going to be building a gesture-based interface for control, and you can use it to control almost anything. Maybe you want to control a robot or a video playback on your laptop. And in this tutorial I'm going to be using the Arduino Nano 3 BLE sense to achieve this. There's an inertial measurement unit on this board, so that consists of the accelerometer, the gyroscope, and the magnetometer. But we're only going to be using the accelerometer to take movement in the x direction, y direction, and z direction, and then we're going to be using that to train how our ends move in a certain direction, train a model based on that, and then deploy the model back on the Arduino board. And towards the end of this tutorial, I'm going to be using that gesture to control a video playback, to play a YouTube channel video, to pause, and then to pan the video. As I mentioned, you can use it to control almost anything, just based on what you want. Yeah, and also I wanted to mention this. It's been a long time since my last video on TinyML. I have an IEEE conference coming up ending of the year, and I was working on a research paper that I needed to finish up and submit for the conference. So I think everything is back now. We should get all the tutorials ready, and you're going to be enjoying a lot of tutorials coming up after this. Also, after this particular tutorial, I'm going to be making another tutorial using the same principle also, but then deploying the model on Arduino RP2040. I mentioned this as one of the boards we use for TinyML at the very first part of this series. This Arduino RP2040. You can also deploy a lot of models on this. That's a lot of functionality also. And even learn more about this particular board and the slight difference between it and the Arduino Nano 3 BLE sense. You can watch out for the next tutorial. I'm going to be doing the same thing. I'm going to be deploying a gesture-based interface on this particular board. And after that, immediately, I'm going to be exploring the principle of edge impulse forwarder. That's a data forwarder that's come with edge impulse. And for that, I'm going to be doing exactly the same principle, but using the Raspberry Pi Pico. I'm going to be, one thing about this board is that it doesn't have IMU unit, that's inertial measurement unit, unlike the other two boards that we've looked at initially. So this particular board, I have to use an external sensor, and I'm going to send data from that external sensor, a gyroscope, that's MPU 6050, sending it to edge impulse. And in that particular tutorial, I'm going to be looking at edge impulse data forwarder. So if you want to learn more about how to send data from almost anything at all to edge impulse, you can watch out for that particular tutorial. It's going to be really interesting. And then I'm going to be training the model on edge impulse and deploy it back to the Raspberry Pi Pico. But in this tutorial, let's just focus on the Arduino Nano 3 BLE sense and get everything ready. So let's get straight into it. There's not much of hardware setup for this tutorial since the sensor we are using is also on board. So we're going to set up hardware. Once you have your Arduino Nano 3 BLE sense, you are good to go. And as I mentioned, we are going to be using edge impulse to train the model. We are not going to be using Google Colab. It's going to be on edge impulse. So I'll just simply search for edge impulse. You can just come to edgeimpulse.com. But one thing I advise is that before you even go to edge impulse at all, if this is your first time of trying to work with the onboard inertial measurement unit of the Arduino board, you can just simply come to Arduino Nano 3 BLE sense, and let's see, just maybe Nano 3 BLE sense, not lights BLE. So I just want you to maybe see how the accelerometer works, and to do that, just come to Arduino Nano 3 BLE sense, the official documentation. And if you go to the tutorials, if you click here on the tutorials, there's a place that explains on, so just go through this. Yes, this particular part that says accessing accelerometer data on Nano 3 BLE sense. You can just click on this. Now, take time to read through if this is your first time of working with the accelerometer. This explains a lot of things. You'll be able to know how the concept works. You can see how the diagrams are being arranged, the x direction, y direction, and the z direction. It's very straightforward to get started with this. Just plug in your Arduino board and copy this code and paste it on your Arduino IDE and see if you can just get your accelerometer data to be visualized on the serial monitor. Yes, on the serial monitor. So once you have that and that is fully functioning, you can jump straight back to edge impulse and let's train the model together. This is the first thing I would recommend you do if this is your first time of working with the inertial measurement unit. Now, jumping back to edge impulse, I'll log in. If you don't have an account, create an account and log in. We're not going to be doing the initial setup and how everything works in this tutorial. If you want to learn more about that, this is a tutorial where I explain how to set up your Arduino board with Edge Impulse the first time, I'm going to be dropping a link to that in the tutorial section. Just, it doesn't take time. And if you don't want to go through that, you can just again if you just come to Edge Impulse Arduino 93 BLE license. You can just search for Edge Impulse Arduino 93 BLE license, and here we have a documentation. This is very straightforward to follow through. You can just come to the documentation and read on how to connect your Arduino Nano 93 BLE license to Edge Impulse. You need to do a few things. You have to go through this. You have to install the Edge Impulse CLI, follow and install the Arduino command line interface, and by the time you are done, you're able to connect your board to the Edge Impulse platform. But if you find it difficult to follow this tutorial, this right up, I will be dropping a link to a video I made on this, on how to connect your 93 BLE license to Edge Impulse. So once we have that ready and that is fully functioning, just come back to Edge Impulse, and then we are going to create a new project. So just click on create a new project, and then you can call your project any name at all. Let me call this the three. Let me call it 93 gesto. So you can call this anything at all. So create project. So once that is done, the next thing you want to do is to connect your board to your laptop. So I'm going to be connecting mine now. I've not connected it. Plug that in, and I plug that to my computer. Yes, so after plugging that in, I'm not able to show the camera now. So I've plugged the Arduino to the computer now. So one thing I have to do is to, if you've been using your Arduino board for other things before now, you have to run the Edge Impulse firmware on it. If it's your first time of setting up your Arduino Nano board for Edge Impulse, when you follow the guide that I mentioned here, the guide here is going to, you don't have to do this because you'll be doing it along the way also. But if you have been using the board for some other things, you need to run this again so that your board will be able to connect to the Edge Impulse. Now, what I need to do is to go to my file. I downloaded it, and when I was setting this up, again, I shared the link that you are going to follow to set up your 93 BLE license to Edge Impulse. Everything is going to be there. So this is what I downloaded, and everything here is what you've seen. If you're going to see this if you are setting up the board for the first time when you follow that guide, and if you have been doing it before, you've connected your board to Edge Impulse before, you also have to come here. I'm sure you downloaded this back then. Just come to where you downloaded it, and you're going to flash the board again. So click on flash Windows. If you're on Windows, if you're on Linux, click on this, and if you're on Mac, you have to run this. So let's double click on flash Windows, and make sure your board is connected as at now. This is going to flash my board, and I'll be ready to connect the board to Edge Impulse. So that is done, and then it says any key to continue. Yeah, done. So going back to Edge Impulse, let's see. Though I've not connected now, but if I come to devices, you see that it says no device is connected yet. So for me to connect a device, I open command prompt, cmd, and you can type Edge Impulse daemon. Again, if you don't understand what I'm doing at all, just follow the tutorial that I mentioned on how to set up your Arduino board with Edge Impulse. Everything is going to be explained. And if you also read the guide I pointed to here, again, is well explained there. So Edge Impulse daemon. So we have serial is connected, our board is connected. Yeah, we have the board connected now. Now, one thing that happened here is that it's connected to my former project. But in this case, I wanted to pick another project. If I still come here, you see, I still have that no device is connected yet. There was a project I was running initially, so it's connected to it automatically. So for me to connect to a new project now, I need to clean it. And I've just closed this and run clean. So now with clean, I have to re-input my details and then select a new project. So you will input your username and then your password. Oh yes, so it's listed all the projects that I have, and the project I just created now is called Nano 33 Gesto. So I just have to use the keyboard to select Nano 33 Gesto, which is the last project here. Select and it's going to set everything up and connect to it. So it says connected. So if I come back, it says, what name do you want to give to this device? Let's just call it Arduino Nano. So everything is done now. If I come back here, you see that my device has been connected and it says the type is Arduino Nano 3 BLE. So one thing I used to discover I can do here, you can just click here that says target and select Arduino. I'm not sure this actually makes much difference, but I think there's a little bit of difference when deploying the model. So just select the board that you are on. Arduino the 3 BLE sense. I'm going to select this and save. So leave everything as it is. Now, after connecting our board successfully to Edge Impulse, next thing you want to do is to collect data. So I click on data acquisition. And again, if this is your first time of working with Edge Impulse, take time to read through maybe the documentation and see how things work on Edge Impulse. So to collect data, I'm going to click on data acquisition, and my device is Arduino Nano that I mentioned. Now, I'm going to be collecting, we are going to be building a model to detect the movement, 3 different movements of our ends. When we move our ends in a circle, when we do a cross sign, and then when we do panning, we move it to the left, to the right, and then back to the left. And also we are going to be collecting data when we are not doing anything at all. That would be the unknown state or the idle state. Now you're going to be giving each of your label, each of your data a label. And the first one I'm going to collect is circle. So I'm going to call this circle. And I'm going to be collecting 50 different samples of circle. This is how I'm going to do it. So the sample length, I'll make this to be 20 seconds. That's 20,000 milliseconds. And now, on that sensor, you have to select. Now, one thing you have to notice here is that the IMU unit consists of accelerometer, gyroscope, and magnetometer. Even though what we only need is accelerometer data, we're not going to be using gyroscope and magnetometer. We're going to select these 3. And we're going to, one thing we are going to discover is that it's going to be reading the 9 data. That's for 3 axes of the accelerometer, 3 axes from gyroscope, and 3 axes from magnetometer. If you're going to deploy a model like this, there's going to be a problem later on. I'm going to show you how to work around this in this tutorial. But again, just select the 3 sensors. There's no way you can select individual sensor. So select the inertia and each of the 3 sensors. So let me just bring up my camera field to show the movement of my ends. So here I have my camera field. This is my Arduino board. And I'm going to be, as I mentioned, I'm going to be using 3 different movements. First is a circle, next is cross, and third is pan. So what I need to do now is to, let me just bring this down here. And to start sampling, just click on start sampling. So once the sampling starts, so you can move in circle. So it's good that after moving a single circle, you can wait a second. I've already made a mistake at the beginning. So you can wait a second so that you'll be able to force to split it later. We're going to see why we need to do this. And this, if this amount of bad data, I only want to use this. Let me take another one. So what I mentioned, I have to start implementing it also. So let me bring up my camera field again. So to start sampling again, I'll click on start sampling. After each circle, I'm going to wait for 8 seconds before another circle. 1, 2. So with that, our data will be well separated and well segmented, which also make it easier for us to split. So we should have a good data set with that. Yes, and we can see here we have each of these distortion in the graph shows when we do the movement. We're not going to be tuning our data based on all of a single graph like this, since we are looking at just a single circle to effect our action. So we need to split this data point into each circle. So to do that, I'll just click on this point and say split sample. So once you click on split sample, we're able to split. No, it automatically picks each of those circle itself. But we want to split it into 2 seconds. I'll just click 2 seconds. And then see our data selection has expanded. Now, most times this will automatically select the circle that you are interested in for you. But if some are not selected, for example, this particular part is not selected, just click on add segments and click on that particular area that is not selected. So it's going to drop a window, a 2 seconds window on that particular frame. And let me shift this here. I also need a new frame here. So I click on add segments and click on this. So this is not able to select everything. I'll just bring this down. Yeah. So it's not up to 2 seconds, but it's well enough for it. So if I count here, this is 1, 2, 3, 4, 5, 6, 7, 8. So I'm able to get 8 data points here. I'll just click on split. And at the end of the day, say I have 8. Each of these data point has been splitted into the individual circle. So just on a single run, I have 8 data points. Now I'm going to be doing the same thing I'm going to be doing this. So at the end of the day, I'm going to have, if you check it, I have just 8 samples of circle. At the end of the day, I'm going to be having 50 samples for circle, 50 samples for cross, and 50 samples for pan, and also 50 samples for unknown. So that's me not doing anything, just resting on the table. I'm going to be doing that. So at the end of the day, I'm going to have 200 data points in all. And it's not only limited to the movement of circle, cross, or pan. It can be anything at all. Lastly, last thing I want you to notice that if you look at this graph, I have nine different representations. This is accelerometer in X direction, accelerometer in Y, accelerometer in Z. Same thing for gyroscope and same thing for magnetometer. But what we really need only is accelerometer in X, Y, Z. We do not need gyroscope and magnetometer. This is another problem we are going to be solving, and we are going to be removing these other 6, and be focusing on just 3 while building our model. Once you are done taking all your data sets, as you can see here, if you check, I have my training to be equal to 200. I can click on any one of these. So this is unknown when I wasn't moving my ends at all. To filter, let me show you some other of my sample. So let's just say we want to see the pan. So I have just the pan. If I click here, you can see how the pan looks like visually. And again, let's check how cross looks like. So we can see for this is also pan. I'm choosing cross. No. Yes, cross. So this is how cross looks like. And if I select circle, you also see how circle looks like. Now this is circle. And also one thing you notice, as I mentioned earlier, is that this is showing the data point for all the 9 inputs: accelerometer, gyroscope, and magnetometer. So after getting your data set, the first thing you have to do is to split this data set into test, train, test, split. And to do that, just come here and click on this details button, clicking here. So why we do this is to be able to train our data and be able to test it on unseen data to actually test whether it can generalize well to unseen data or not. This is very important and one of the good steps that we do in machine learning, so that we can validate our model and make sure it can generalize well to data that it has not seen before. And to do this, we can just click on perform train, test, split. If I click here, it's going to ask me to confirm this and then say yes. So to do that, you have to type in perform split to continue, because this is sometimes I don't want to do this. So I'll just perform split and perform train, test, split. So once we're done with this, we see that our training set is now 80% and our test set is 20%. And we check our training is 159 data sets and test is 41 data set. Immediately you are done with the train test splits. I don't know, let me check. My device got disconnected. Alright. So once we are done performing the train test split, we have to start designing our impulse. And to do that, click on create impulse. Now you have to leave everything as it is, like this. What window size means is that our data, our model is going to be training on a window size of 2 microseconds. That's 2000 microseconds. That's 2 seconds. If you remember, when we were taking our data sets, we were taking it in samples of 20 seconds. And after taking a 20 seconds, we later split it into 2 seconds by selecting just individual circle or cross out. And that window that we used was 2 seconds. So that's why we have this as 2 seconds. Our data is going to be, our model will be trained on a 2 seconds time frame. And this principle, the principle we are going to be using is a sliding window principle. You can read more about how this principle works. Basically, when we take continuous data, when we deploy our model, we take continuous, we keep on doing our ends in a circular position continuously. It's going to be calculating and monitor the last 4 the last 4 gestures that we performed, and then check if they are consistently the same. If they are the same, it's going to then it's going to perform inference on that same motion and give us the motion that we are doing. Give us the gesture that we are currently on. You can read more on how sliding window works. So now we have our window size to be 2 seconds and window increase to be 200 milliseconds. We have to add a processing block, and in this case, if you read here, you see IMU, syntax, spectral analysis. Whenever we are dealing with things around motion, voice, it's better we use spectral analysis. So I'm going to be using this add. And as you can see, our input axis, there are 9: accelerometer, gyroscope, and then magnetometer. But even though I will have said, since we are taking our data using the 9 axis, it's also good that we train our model using the 9 axis and deploy our model using the 9 axis. But if you are going to go in this direction, we're going to run into problem later on while deploying the model, because Edge Impulse, the provided example by Edge Impulse, does not cover for the 9 axis. It's only covered for the accelerometer. So, and then most times we are good in this kind of scenario. The accelerometer is perfect for what we want to do without needing the 2 other sensors. I just select just the accelerometer and then deselect the magnetometer and the gyroscope, so that our model will be trained on just these 3 axes. So after doing that, I'm going to add a learning block and select classification, since we are classifying 4 different samples here, and our features are circle, cross, pan, and unknown. Then I'll click on save impulse. So after clicking that, we now come to spectral features, and we don't really have to do anything here. This is unknown. Let me select to show us how the other one looks. So let's say pan. So we can see this our 2000 microseconds window. That's our 2 seconds window, and our data will be trained on this complete circle. So we don't need to do anything here. So we can just click on save parameters, and then after saving the parameters, we generate features. The job completed, the features have been separated, and you can see our data are clearly, they are distinct from each other. You see, this is unknown, this is circle, this is cross, and this is pan. We should achieve a lot of accuracies after training this model. So after doing that, we come to classifier, and yeah, you see our input layer is 39 features, a dense layer, another dense layer of 10, and then we can add any extra layer. So what I want to do here is that I'll add a dropout layer of, I'm going to add a dropout layer of 0.2. Here is it. Okay, yeah, dropout. So we can have maybe 0.2 dropouts. So that's to improve our model. So that layer, and I'm going to add this just in between the first layer and then the second layer. So you can just to tweak this, probably you can make your first dense layer to be 39 also, and then that dense layer to be let me do with this first, and then we just tweak it and then see how it changes. So I'm going to click on save and train. Let's see how this perform, and then we also change it and then see how things perform. What we are working towards is to get a very high accuracy as much as possible. So let's see what we are going to get after training our model using 30 epochs. The first layer is 20, that's 20 neurons, and the next layer is 10 neurons. So after training this, we have 71% accuracy, which is quite low, because the other time when we saw our spectral features, they are distinct from each other. They are clearly separated from each other. There's no reason why we shouldn't get 100% accuracy in this case. So let me go back to classifier and then retrain our model on new parameters. So I'm going to make this to train 100 epochs, and I'll make the first. You can tweak any of these parameters at all to get a higher accuracy. So I can make this also to be 39, the first dense layer to be 39, and then I can put a dropout rate and then next layer to be 10. So let me save and then run this again. Let's see if the accuracy is going to increase. Oh well, as you can see that here I have 100% accuracy. So who doesn't like 100% accuracy? That's nice. So once that is done, we are done training our model. So you can also maybe tweak any of these parameters to see how each of the parameters affects your model's accuracy. You can see we have area under the ROC curve is also 1, precision is 1, recall is 1, and F1 score is 1. And you can see also our data, they are separated from each other distinctly. Now, next thing, we can just go ahead and deploy the model on the device directly. But before I do that, I want to perform a live classification, or we can also do a model testing. And that might be the first thing that I'm going to do. Initially, don't forget that we split the data into train, test, split. This is just a training accuracy. We are not sure whether our data will generalize to unseen data or not. So to be able to show off that, we have to click on model testing, and we are going to test our data based on the test split. So I click on classify all and see how the data will perform on unseen data, how the model will perform on unseen data. Yeah, good. We also have the test accuracy to be 100%. Our model performs quite well. One thing is that we can't always judge how the model will perform on the device. There might be a lot of dropout, a lot of buffering, overload that might happen while on the device. So we might not achieve up to 100% accuracy while testing the model on the actual device. What I have to do, I always like to do, is to do live classification. Here you're able to somehow deploy the model on the device, but we're also doing the classification while still on edge impulse. Now, I want to take the data again. Our device is the 3 BLE, and the sensor we are using is gyroscope, accelerometer, and magnetometer. And sample length is 10. This is going to sample over 10 seconds, and I will click on start sampling. Now I'm going to pick up my device, and then I'm performing the circle motion now. So circle motion, as you can see, we have timestamp showing that we have circle in almost all the cases. You can see 0.99%, showing that I'm actually doing the circular motion. You can also do this for pan, for cross, for anything, and just test if your model is actually working fine before you deploy it to your device. So once you are sure and then you are satisfied with the performance of the model, just come down here and click on deployment. So deployment, and you are deploying on Arduino, so you can search for Arduino library. So I click on Arduino library, and again, make sure you select Arduino Nano 3B license here and click on build. So once our model is ready, we open up our Arduino IDE and upload the code. Whenever we are doing the circular motion, it will print out on the serial monitor that we are doing circle. If you are doing pan, it will show it is pan. If you are doing cross, it will show it's cross. And if the board is just lying idle, it will show unknown. Now, once the library is done building, it will give you opportunity to download it. I'll just click on save. So with that, I have my model downloaded. I can now open up my Arduino IDE and set things up there. Once the library has been downloaded, just open up your Arduino, and then we are going to add the library to the Arduino IDE. So to do this, just come to Sketch and then include library. So just if you go up here, you're going to see add.zip library. I'm going to be clicking on this, and then you select the library that just got downloaded. It was a zip file, so it was saved in desktop, and I have it edge EI33 1.0.5 open. So once it's done, you show library installed. So you have the library has been successfully installed. And to run some examples here, just come to File, under Examples. So you're going to see the library listed, which is A33 BLE gesture inferencing. Under this, I'm going to select the 33 BLE sense and the continuous example. So I click on this. You open this up, and then we can upload it to our Arduino board. Take note that this might take some time to upload. If it's taking time, just give it some time. It might take a little bit before it got uploaded. So there's something you don't have to do any form of modification here. As I mentioned initially, if you select those three axes, just the accelerometer, you don't have to do any form of modification. But if you select more than three, this might not really work fine, though you're able to upload the code on the Arduino board, but there might be some problem that will arise later on. So just stick to those three and then select the port. Tools, the port is COM6, and then we can click on upload. So once the code is done uploading, yeah, we have uploaded 100%. I just open up the serial monitor and see this. If I open it up, you can see, let me open up my camera view. Now the board, I've found a way to attach it to my hand. I'm not making any movements now, and I have uncertain. So let me start doing the panning. So after some time, you can see that it shows that I'm performing the panning motion. The same thing applicable to cross. Yes, and then we have cross. So the same thing applicable to doing the circle motion too. You can see just pop up the circle that I just did and then close it up again. So the same thing applicable to circle motion. Now we know that we've been able to deploy our model on the Arduino board to recognize the shapes of the circle gesture, cross gesture, and then the pan gesture. So the next thing we have to do is to find a way to pan this and then port it to our keyboard so that it can control a YouTube video playback. Now before doing that, one thing I want to edit here is that if you notice, I have all these things being displayed on the serial monitor, and I only need the prediction which is being shown on this particular column. So what I need to do now is to clear everything that I have and just leave the prediction, maybe the circle, pan, or cross. And to do that, I'll just go to where this is being displayed, and you can see it's been displayed there. Yeah, it starts from here where you have the prediction. So I'm going to just comment this out. This is going to be left, and then I'm going to comment this out also. Yes. And instead of putting edge impulse print here, I'll just change it to serial.print. Serial.print L. So you have to save this and then upload it. So I'll just upload this code and monitor it on the serial monitor again. And once that is done uploading, I'll just open up the serial monitor and then bring up my camera view. So during the motion of pan, so we see that the thing we have on the screen being displayed is pan, and if I'm doing cross motion, so the only thing I have been displayed on the screen is cross. So I can now write a Python script to what's been displayed on the serial and then use that to control a YouTube playback video. One advantage that we are going to leverage on in this case, let me open up my IDLE. The Python script has been prepared already. I'll just walk you through. how they work. So I have the Python script prepared here. One way we are going to take advantage of the gesture is that if you are watching a YouTube video, whenever you press M, it's going to mute the video, and whenever you press M again, it's going to unmute it. If you press K, it's going to play or pause the movie, and if you press the Shift N, it's going to change the video. So we are going to leverage on this keyboard shortcuts, and then whenever what this condition is doing is that whenever it says circle, don't forget here I've already opened the port to be COM6. I'm using Python serial. If you've been following this tutorial, you will understand how this works. So port that I'm using is port COM6, and I'm going to use this Python code to open the port, just like what I'm seeing on the serial monitor. I'm just again reading the serial port using a Python code. And whenever I see the word circle coming from the serial monitor, I'm going to press M using the Py2GUI library. And also when I see the word cross, I'm going to press K, and when I see the word pan, I'm going to press Shift N, and at the same time it's going to control a YouTube video like that. So I've just run this. So while this is waiting, let me open up a YouTube. You can just open this up or use maybe one of the videos. For example, yes, I have a video on TinyML. I just click on watch on YouTube. So we're going to be using this video as an example. This is not long as I want. Just 2 videos. So let's use the class tutorial as an example. So I'll go in there, and then I'll just choose, okay, this was the last tutorial. I'll just pick this and use this as an example. So let me bring up my camera feed. If I'm doing this is cross, I'm expecting the video to, once the scene pause, I'm expecting the video to play and pause from the cross. So we can see it's actually controlling. So I'm opening this up now from, so the video is being played based on my hand gesture. When I open the two at the same time, when I open my camera feed and the video, it tends to stay on the active screen tends to be the camera feed. So let me just reduce this in size. So this is my camera feed and this is my video feed. So if I'm doing the cross symbol, so I'm able to pause the video from the cross symbol, and I'm going to play it again. And if I'm doing the pan, so you can see that it changes the video to another video entirely. So I've done it a couple of times, so it begins to change to multiple videos, and then it's playing very long now. So this is just a simple application to controlling a YouTube video playback. You can apply this to maybe controlling a robot, controlling a self-driving car, or any form of project at all that you have, and then you want to control it using manual control. You want to use a gesture control form. So thanks so much, guys. I hope you find this tutorial useful. I hope you really love it. If you like, don't forget to give me a thumbs up, a like, and please subscribe and share the video to anybody that might need it. Don't forget, in the next tutorial we're going to be looking at how to do the same thing but using RP2040 board, and following that you're going to be using the Raspberry Pi Pico to do the same project exactly. So thanks so much again, guys, for joining me in this tutorial, and I'll see you in the next tutorial.